Morning students, welcome back to the YouTube channel of Venus Public School. We will continue with chapter 3 of class 7, which is structure of matter. Yesterday we have discussed about chemical formulas. Okay, so what are chemical formulas? Chemical formulas are the representation of a compound using chemical symbols and its constituent. Clear? We have taken some examples, and as we have seen yesterday that hydrogen and oxygen are two different elements and they combine together. Okay, now you must be wondering, and yesterday we have discussed like how this kind of combination is possible, like how oxygen came to know that hydrogen will be joining it, and they will form a compound. Clear? How sodium come to know that chlorine will going to add with it, and they become a compound. Clear? So this is because of the valencies. Clear? So yesterday we have discussed the valencies. Valencies is basically the combining capacity of any element with the other element. Clear? And when one element combines with the other element, they combine to form a compound. Clear? Now on the basis of valencies, they will be joining. Like not all the elements are able to join each other in all situations. Clear? That means when we are saying combining and joining, we are talking about chemically. And what is chemically? Suppose hydrogen and chlorine. Clear? Hydrogen and chlorine has one valencies. Clear? That means it might happen that it might be possible that one element is having excess of charge, and one element is having one lack of charge. Okay, by 1 unit, lack of charge by 1 unit. One is having lack of charge by 1 unit, and other one is having excess of charge by 1 unit. Okay, what they will do, they can easily like exchange the electrons, share the electrons, and they can form a compound. Clear? So if one element is satisfying the need of other element, then they can combine or join together very easily, and that's how compounds used to form. Clear? Now let us see, let us understand how we are able to write a chemical formula for a particular compound. Clear? So let's take an example of hydrochloric acid, HCl. So here what we need to do is, there are two steps only. There are few steps. Okay, so the first step is, what we need to do is write the chemical symbol. So here we have written hydrogen as chemical symbol of hydrogen, H as a chemical symbol of hydrogen, and Cl as a chemical symbol of chlorine. Clear? So C is capital here and L is in small, chlorine. Okay, you remember the rules of writing a symbol? Yes, it is. So chlorine, hydrogen, chlorine we have written. Now what we need to do is, now we need to write down their valencies. In the previous topic we have discussed, we have seen the valency of hydrogen is 1. We need to memorize it. Because there is a logic, there is a concept, but you are going to learn the concept of these valencies in further classes, in class 9th maybe, or in maybe 10th. Sorry, in 9th class you will be able to learn it, but for now you will have to memorize it. Whatever valencies are given in the book, you will have to memorize this table. There is a table given in your book in which some most commonly used elements are there and their valencies are given, so you need to memorize it. So basically, when we are talking about hydrogen and we are talking about chlorine, what are the valencies? 1 and 1. Clear? So what we need to do over here is, while we are writing a chemical formula, first of all we need to write the symbols, then we need to write just beneath the symbols we need to write their valencies. Okay, I have written the valencies. Now what we need to do is, we need to cross them. Okay, we need to make a arrow like this. Okay, in cross, like clear? So while we are cross over the entities, while we are cross over the valencies, and after crossing over the valencies, we need to write these crossed valencies, okay, with the cross symbols as a subscript, SUBSCRIPT, as subscript. You know what is subscript and superscript? Superscript, let me tell you. Suppose if you are writing something on the top like H2. Clear? So this is superscript and this is subscript. Clear? This is subscript basically. Clear? So while you are writing anything in a small way, okay, at the bottom, that will be called as subscript. Clear? So if we are writing it H1 Cl1, because H1 and Cl1 crossover, okay, so H1 and Cl1, so as one has like we can it is the rule of arithmetics that if one is there is no need to write it. Clear? So HCl would be the compound. Clear? So let us try the same thing with CCl. Okay, carbon tetrachloride. Clear? So let us do it. Let us try to do this. First of all, we will write chlorine. Then second, we will write carbon and chlorine. Clear? We have written carbon and chlorine. Now from the table we will able to find out what is the valency of carbon and what are the valency of chlorine. So carbon is having the valency of 4 and chlorine is having the valency of 1. Clear? Carbon 4, chlorine 1. So let us write it like this: carbon 4 and chlorine 1. Clear? First step, writing step number 1, write the chemical symbols. Step number 2, write the valencies just beneath the symbols, okay, respectively. Like we have to write carbon, just beneath the carbon we need to write its own valency, just beneath the chlorine we need to write its own valency. Now we need to cross it, okay, like this. While we are crossing it, now what we need to do, we need to write valency, this crossed valency with carbon in subscript. Clear? And we need to write this valency, this crossed valency with chlorine in subscript. So what we are going to do, C1 and Cl in subscript 4. 1, there is no need to write 1, so CCl4. Clear? CCl4. Basically carbon is having 4 valencies, chlorine is having 1 valencies. Okay, so 4 atom of chlorine satisfied the valency 4 valencies of carbon. That's how they combine together and they form a compound. They combine together, these elements having valencies combines together and they form a compound. Clear? So carbon tetrachloride is formed, and this is how we are able to write the formulas. Let us take one more example, few more examples, and then we will move further. So let us write the formula of magnesium oxide. Okay, magnesium oxide. So I don't know whether it is not given in here. Magnesium oxide. Okay, so first of all, magnesium and oxygen we need to write. So what is the valency of magnesium? Magnesium is having valency 2 and oxygen is also having valency 2. When we cross them, what will happen? Basically 2 valencies are there. So what will be happening here? We crossed it and we will write Mg2O2. Clear? Or if there is common, then we can write 2MgO as it is common. So 2 molecules, when you add like this, molecules of MgO is formed, and you can use this to represent 2 molecules of when you use to add MgO, then magnesium oxide will be formed, and MgO is the product and 2 molecule of it is produced. Clear? Okay. And similarly calcium hydroxide. This is magnesium oxide and calcium hydroxide. Calcium and OH. Okay, hydroxide is another compound. Clear? Calcium is another compound. So we have discussed what are compounds. Compounds are basically mixture of 2 elements, or maybe combination of 2 elements, chemical combination of 2 elements, 2 or more elements, or a compound with an element. It also forms a compound with a element. Clear? So What is the valency of calcium? 2. Hydroxide is having the valency of 1. So when we cross it, what will happen? CaOH as a compound hold twice. Clear? Ca1 and so calcium OH hold twice. Calcium hydroxide. Clear? This forms calcium hydroxide. So these are few examples of combination of substances, combination of substances, or this is how we are able to write the chemical formulas of any substance. Clear? But for that, what are the two things we need to keep in our mind? Number one, their symbols. First of all, we need to write their symbols. Second, we need to write their valencies. We need to memorize the valencies, or understand the concept of valencies, and then we cross the valencies and write them and as a subscript. This is what 3 steps. In 3 steps we are able to write down any chemical formula. Clear? Now, as of now, we have learned what are elements. Okay, as elements are having only one atom in it, or single type of atom in it, and compound are the chemical combination of what elements. Okay, or more than one elements, or one element with a compound. Clear? Now, what is atomicity? Atomicity is basically while a compound is formed. Okay, while a compound is formed, or an element which is existing in the nature, see, like water. Water is a compound which exists in nature. Hydrogen is a compound which exists in nature. Clear? Oxygen it's element, compound, carbon dioxide compound. So these are some examples of substances which are existing in nature. Clear? These are some examples of elements and compounds which are existing in nature. But in nature, their existence is like few of them are not able to exist in the nature independently. Clear? Like oxygen. Oxygen is not able to exist in nature in a single molecular state, in a single atomic state, like one atom of oxygen will never exist in nature. Clear? We always used to write oxygen as O2. Why O2? This 2 represents 2 atoms of oxygen combines together and thus form one molecule of oxygen. Clear? Right? So similarly, like hydrogen. Okay, hydrogen also not able to exist in the nature in monoatomic, like in single atom state. Okay, we need to add H2. Clear? 2 as subscript, which represents 2 atoms of hydrogen is there in one molecule of hydrogen. 2 atoms are there. So basically, what we are representing here, we are representing the different atomic states of elements and compounds, okay, and thus they will be termed as monoatomic, diatomic, triatomic. So this is what telling us the atomicity. What is the atomicity of? So what is the atomicity here? Here 2 atoms of hydrogen plus 1 atom of oxygen will give you 3 atoms. So what is the atomicity here? 3. Clear? 1 atom of carbon plus 2 atoms of oxygen will give you 3. So atomicity is 3. Here atomicity is 2 atoms are there. Total number of atoms of oxygen are 2. Okay, clear? Now chlorine exists in single atoms. Okay, so monoatom means one atom, monoatomic. Okay, diatomic means 2 atom. Mono means 1, di means 2 atom. Okay, tri means 3 atom, tetra means 4 atom, and so on. Clear? So atomicity can be explained with these terms. So now onwards, whenever you listen these terms, monoatomic, diatomic, triatomic, tetraatomic, you have to keep this in mind that in nature some elements are not able to exist in free state or single atomic state, that means only one kind of atom, one atom is not able to present or exist in the nature. That's why they combine, they join together with same type of atom and form monoatomic, diatomic, triatomic or tetratomic states. Clear? So what is the conclusion of atomicity? Atomicity is basically the number of atoms present in one molecule of an element. Clear? The number of atoms present in one molecule of an element is called its atomicity. Clear? So number of atoms present in one molecule of present in one molecule of an element. Clear? So this is what atomicity is. So far we have discussed symbols, chemical formulas we have discussed valency, we have discussed atomicity. Now chemical equation. The next topic is chemical equation. Clear? Before moving further, I need to tell you few examples of all these, like helium. Helium is monoatomic. Okay. Sodium is monoatomic. Na, sodium. Potassium is monoatomic. So these are example of monoatomic. Clear? Now let us talk about diatomic. Diatomic is hydrogen. Okay, hydrogen, oxygen. I have already given you the example: hydrogen, oxygen. Okay, chlorine, O2, H2. So basically in nature they are not able to exist in monatomic state. That means only one atom of chlorine is not able to exist in nature. Only one atom of oxygen as well as hydrogen is not able to exist in nature. For their existence they need to group up with another atom. So in nature they will be existing in diatomic states. Clear? Now phosphorus, P4. Clear? P4 is the example of phosphorus. P4 is the example of tetraatomic. P4 tetraatomic. Okay, triatomic is ozone, O3. Ozone layer, you might have heard about ozone layer. Ozone layer, that means 3 molecules of oxygen combines together and thus they form triatomic state of the oxygen, which is ozone layer. Clear? And which plays a very important role. So this sometimes we will discuss how this is formed, this O3 layer is formed, and what is the function of this ozone layer. Clear? So this is what atomicity is. I have given you some examples also. Now, so tomorrow we will be discussing chemical equations, how chemical equations can be written and how they are formed, and what are the different rules and representations of chemical equation. Okay, thank you.